The broadcast is now starting. All attendees are in listen-only mode.
Good morning, good afternoon, good evening, folks. Thank you for tuning in to another episode of our Best Practices webinar series with 7Signal. So if you'd like to, please let us know where you're logging in from in the Q&A panel, the chat panel, and we'd love to see where you guys are joining us from. If you're working from home, if you're working in the office, I'm actually working from home today in my apartment in Cleveland, and Dave is also working from home. Dave, where are you tuning in from?
I'm in beautiful Kent, Ohio.
Lovely. Awesome. And I'm new to the area. So how far is that from where I am right now?
Like really far.
Really far. Okay. There you go.
Yeah, I'm actually east of Akron.
Okay.
And so the headquarters is kind of like just south of Cleveland.
Got it.
So I'm about, like, it depends on what time of day. Like if it's after 5, it's more than an hour.
Okay. Awesome. Not too far then, not too bad. We got a few of you entering in where you're joining us from. I see that we have Cheryl from Pittsburgh. I recognize that name from last week. Welcome back. Let's see who else we have here. We have Fabiano from London working from home. Thank you for joining us today. We also have Paul tuning in from Chicago. We have Daniel tuning in from Minneapolis. Let's see what else we got here. And we have Dan joining us from Stockholm, Sweden. Welcome back, Dan. Well, thank you guys so much. Keep dropping that in there. We'd love to know where you're joining us from, and we will go ahead and get started here today. So we are 7Signal, the leader in wireless experience management. Now, what exactly is wireless experience management? We'll go a little bit more into depth with how that aligns with our 7Signal mission later on in the webinar today. But just to introduce myself, my name is Kelsey Rizzuto. Some of you who have been on our past webinars may recognize me. I've kind of been a cameo for the past couple of weeks. I am a new marketing specialist at 7Signal. I joined the team about 3 months ago, I believe. And as I said, I recently moved to the Cleveland area. I'm really enjoying it so far. So I'm excited to actually lead a webinar here today with our special guest, Dave Hallis. So Dave, I believe the last time you were on was about a month ago, and I think we talked about power savings and Wi-Fi. Is that correct?
Yeah, that's right.
That's
Good
right.
memory.
Well, thank you. Also, I remember that on our last webinar with you, unfortunately, you missed a wine delivery to your home. So, and that might happen again today. So let's keep us in the know of what's going on, because we'd love to hear about it.
Okay. If I do see him, I do have a backup plan. I have a baby boy Hallis. He said he's standing ready to act accordingly if there's a delivery.
Perfect. We're prepared this time. Awesome. All right, well, we've got a great topic here today with Dave. We're talking about IEEE 802.11, IoT, and the impact on endpoint capabilities. A lot to unpack there, so let's get started. A few announcements just to start off. Again, if you've joined us in the past, a lot of these will sound familiar. But just to recap, we do partner with CWNP for every single one of our webinars. And by watching these webinars, you are eligible for CE credits. So if you're pursuing a certification, no problem, just shoot us an email and we will get a certificate over to you shortly for that. Additionally, we host a product tour every single Friday at 12 noon Eastern. At that link, go.7signal.com/tour. And no worries, we'll drop that link in the chat later if you want to register for that. But we don't really get into the product or any kind of demo on these Wednesday webinars. The purpose for these Wednesday webinars is really just to educate, to learn, to connect with our community of wireless engineers and friends, to really go through these topics and best practices and troubleshooting tips so we can put our best foot forward in correcting connectivity issues. Additionally, we post all of our archived webinars on YouTube. So this webinar will actually be posted later this afternoon. So you can go back and rewatch some of your favorites there. And we're also very active on Twitter. So go ahead and give us a follow at 7Signal. We also post our PowerPoint slides after every single webinar to our Twitter account. So you'll be able to access them there. But if you don't have a Twitter account, no worries. Just shoot us an email and we'll be able to send the slides to you per request. Another reason to follow us on Twitter is we've recently been giving away a lot of 7Signal merchandise for people who follow our Twitter account and engage with our trivia. So I'm going to go ahead and read some of last week's winners, who are some lucky recipients of 7Signal swag. So last week we had Jean-Pierre Como, Keith Miller, James Oddbody, and Joe Walker. So congratulations to you four. You should be receiving some merch in the mail soon. And by following us or engaging with today's trivia question, you all can have a chance to win some merch as well. Just to give you a little background on 7Signal, we were established in 2007 in Helsinki, Finland, and we are now located in Cleveland, Ohio. We've hit a lot of major milestones along the way that we're really proud of. We're proud of the 1 billion data points that we're analyzing daily, 5 million devices monitored daily as well. We have over 200 customers, over 30 partners, and 14 patents, which essentially means that the technology that you see from 7Signal, you are only going to see from 7Signal. Additionally, we are certified in over 40 countries, and we are GDPR compliant for our EU folks on the line, which essentially means that we take privacy very, very seriously for all of our customers across the globe. So moving on, as I discussed, we specialize in wireless experience management. And what we aim to do is to enhance the digital experience of all of our users so that you're focusing on what matters most and not focusing on connectivity issues. And how we do that is we provide full visibility into the end user experience through an outside-in approach through our platforms of Mobileye and SapphireEye. We're also AP and device agnostic, which essentially means that what we provide is incredibly complementary to those amazing tools and technologies that you already have installed on the network. Now, what we do is we help to identify the top 7 Wi-Fi problems. For example, when IT is contacted, it's usually never to say that the network is running smoothly, there are no problems today, everything is great. There's always a time-sensitive issue that needs to be resolved quickly, and it usually bubbles up to one of these top 7 Wi-Fi problems: congestion, coverage loss, co-channel and radio interference, roaming issues, etc. And how we identify those top 7 Wi-Fi problems is by running active and passive tests on the edge of the network, trying to detect things like packet loss, latency and jitter, adapter and driver issues, so you can get full visibility into what's occurring in your wireless network environment. Now, just to kind of clarify what makes 7Signal so different is if you look at a typical LAN infrastructure, you've already got great tools, great technologies providing very useful data to you that are already installed on the network, such as your Riverbed, Cisco, Aruba, etc. But what 7Signal does is we take it one step further, moving into a different space by giving you visibility into the user experience from the outside in. And through that, we're able to utilize Mobileye, which can essentially be installed on any mobile device from, laptops, mobile phones, Zebra scanners, workstation on wheels, etc. And it can be installed on any Mac, iOS, Android, or Windows device as well. In addition to that, we also have SapphireEye, which are the sensors installed up in the rafters, looking down on the environment from a much larger scope, giving you that surface level quality and RF visibility as well. So you can get a full perspective as to what's occurring in that environment. What we can also do is give you that external network visibility. All of those great tools and technologies that you have on that enterprise LAN infrastructure, you're not really using now at your home office. Work from home is definitely here to stay, and it's not going to go away. And we have troubleshooting issues and errors that we need to resolve quickly so that we can stay productive and keep working in the midst of all of these unprecedented circumstances. So with Mobileye, we can gain that visibility into those home networks as well. Whether you're working from a coffee shop or from your multi-tenant apartment, your home, we can find that full visibility into your personal user experience as well. And as I said, work from home is here to stay. And all of you know this since a lot of you are working from home today and tuning in. But for example, as we're on this webinar, 76% of remote workers are using video conferencing as a part of their daily work. So with our ability to provide Mobileye, we're able to give that visibility into your home network so that you can stay productive and you can have a great user experience no matter where you're working from. Now, in addition to all of this, we're giving a give back to help with these kinds of errors that people are experiencing at home. So we're offering a free trial for Mobileye, 50 devices for 50 days, and we'll go ahead and drop this link in the chat later in the webinar so you don't have to write this down at all. Okay, and with that, we are going to launch our first trivia question for today. And as I said, by answering this trivia question, you'll win a chance to possibly get some 7-signal merchandise. So go ahead and drop your answers in the poll, and I'll go ahead and launch this now. Let's see here. Okay. All right, so keep answering this question here. We'll let these answers roll in, and we'll ask Dave how everyone did. I see things speeding up a little bit here. Give it a few more seconds for you all. All right, we have about over half of you answering. And we will go ahead and close the poll. All right, Dave, are you able to see the results from this poll?
Yes, I can, and they look good.
Okay, awesome. Great. Can you explain this a little bit more to everyone on the line?
Sure. That there a lot of times people always want to talk about faster, faster, faster with 802.11. And there's 802.11be, which is a task group that's taking a look at how we can kind of go faster with wireless. And so I just thought it was a little bit of a silly question to say, well, what is 802.11ba, the one that's going to make things go faster? And I think probably the people that 32% that answered true, they're probably saying, oh, this isn't about that. I don't want to be here. No, this is 802.11ba is about wake on radio, and it's not really about increasing the throughput.
All right. Well, thank you, Dave, for that. And thank you all for answering these questions. And we'll get a few of you some 7-signal merchandise by next week. And I believe Don will go ahead and pass the controls over to Dave so he can get started and introduce himself.
Okay. So I should be able to. Okay, so about me. It's all about me. So I'm a solutions engineer here at 7Signal, CWNA certified. Over 25 years wireless experience, product development, solutions engineering, and industry standards. I was at Cisco for a while at the AeroNet product line, which is down in Richfield, Ohio. I was recognized as a Cisco innovator. That was mostly along the lines of the security work that we were doing. I was also the task group chair for 802.11i for enhanced security. And then more recently, I was the initial task group chair for 802.11ah, which was for sub 1 gigahertz operation, kind of like targeting at the IoT. I was involved with the formation of the Wi-Fi Alliance, and I have a number of patents. I put down 13. I know that there's a number of them there, and I just kind of figured, well, I'll put down 13 because I think that's the number I had at the last point. So now with that, I'll kind of get into 802.11ba and what is this and what are we solving? So as Kelsey mentioned that a couple of weeks ago or a month ago or something like that, I did another webinar which had to do with power saving. And there's always been this kind of changes over time to increase the battery saving. That initially, when 802.11 came out, so that there was a lot of, well, it's not very good at power saving, and there was always kind of like some additional changes that are going on, and that's still definitely true today. And so, what some background on this? That's what you'll end up seeing with Wi-Fi 6 or 802.11ax. You might have heard that there's some kind of discussions about, oh, this is well suited towards Internet of Things. Why is that? Well, one of the things that it has is it's got the 2 megahertz resource units. And that's basically that you've got a smaller bandwidth channel. And so when you're transmitting, that's going to save you some power on the transmission. That's because if you're not transmitting that much data, it allows you to save power on the transmissions. And there's a number of reasons why that 802.11ax is well suited for IoT. And it has to do for like the efficiency of transmissions. When you have these small transmissions and then large transmissions kind of going on at the same time, it becomes inefficient, but 802.11ax took that into account. So there are this movement to say, hey, we've got 802.11ax, which is going to help us. We could kind of start making these Internet of Things devices that you wear, maybe put around the house, and then that you're going to be able to run. Well, should we still try to focus on that power saving for these devices? Is there some other way that we can improve? We talked about the transmissions, having these smaller channels and that helping us. And so is there something else that could kind of be done? And so one of the things that they're looking at here is that basically what we end up seeing is that the radio has to, with these power saving modes, they all seem that you have to kind of like wake up and receive some kind of signal from the access point to say, oh, is there something that I need to do? For instance, I need to, get some information. So therefore, there's a signal that kind of says, yes, there's something for you. Now you have to kind of go off and do something. So there's this receive operation that gets done. And is there something that we would end up having to do? I just found it humorous because I see baby boy going out to receive a delivery. So if I didn't tell him, hey, get out of bed and go get the delivery, because it does come, that they would have been doing. Anyhow, to move on. So what I'm trying to show here is that the idea being, you've got the 802.11 radio, but how if you add another radio? And the sole purpose of that additional radio is to receive these, that additional radio needs to be low power operation. It needs to consume less power than the main radio. Otherwise, there's no point into it. So it's some way to say, okay, we're going to send this signaling over this additional radio. And when that additional radio, that wake up receiver, receives that transmission, it then says, okay, Mr. Main Radio, you need to wake up now. And that's basically the whole idea between this 802.11ba. And so the things to keep in mind is that you do need, this is new hardware. This is not like some existing, just adding some different protocol. This is actually new hardware that would kind of come out both in the client and in the access point for this. It's got this special little radio on it to send some signaling. I've kind of given the document down below is the one of the submissions to IEEE 802.11 document. If you're kind of wondering what does that number mean, 802.11, the 16 means it was done in the year 2016, and then the rest is just the document number. So the thing that I was talking about is you might say, well, you were doing on this last webinar all these advancement in power saving and how it's kind of like changed. You mean that's all going to change all over again? No. The intent is not really to change like the PS pole or the UAPSD or the target wait time or all that type of stuff. The idea is to still use that, but when there's an opportunity that the client needs to wake up and be in receive mode to then figure out if it needs to do something, well, just have the special radio operate and do that for us. And all it's going to do, that special radio is only going to be receive. It's not going to be a transmitter, at least on the client side. On the AP side, obviously, yes, it has to be able to transmit. This submission here was done by Min Park. I think he did a nice job. He was also the task group chair of 802.11ba. And he's trying to give you an idea of, where is exactly that how this is kind of going to work. This was done at the beginning, so it might not kind of be exactly how the standard came out, but it was definitely pretty close. And here, what you end up seeing is that there's a special transmission, the ones that are in that sort of like that bluish color. with a W, and that's the wake up packet that's sent by the access point to the client, and therefore that the client can be in this low powered mode, saying, I'm going to turn off my main radio. I'll just have this special radio on, and it can do two things. I could either have that special radio on all the time, or I could kind of schedule when it's going to be turned on into receive mode. And so the whole idea is keep that main radio off longer when there's no traffic. Because a lot of times what ends up happening, or we're kind of showing here, is where I kind of had that green circle, is that the main radio, it has to power up and then go into receive mode to figure out if there's anything for it to do. And if there's nothing for it to do, then it's, it's kind of wasting a lot of energy. So the idea being, hey, put more of the work onto the access point side so that the client can save more power. Now that the access point will have to do more, it'll have to actually send something down to say, hey, wake up. So it's kind of like, instead of being a schedule to say, oh, I need to wake up at this and setting an alarm clock, and you have the alarm clock go off, and then you say, okay, I got to go off and do something. Instead, it's like it's like your mom kind of going to wake you up, or like me telling baby boy Alice to go wake up to get the wine delivery. And so then once, by me kind of waking him up, he knows to kind of go, kind of get up and expend some energy. So that's the overall idea. So I'm kind of breaking this out a little bit closer so you can kind of see it. That on the top part where it says the WUR stands for wake up radio, and that's where since that radio itself is lower power than the main radio, what you could do is you could just say, I'm going to have that wake up radio always on. So therefore, if I get some signaling about that I need to kind of wake up, that you can kind of go off and do that. Or what you can do is you could also say, just like the previous ones were that with 8 to 11, they kind of say, well, I'm going to go to sleep, and then that there's going to be a certain time where I need to wake up, that I kind of know that. That's kind of like extending that same type of idea, but to the wake up radio specifically. So you kind of schedule that. And so there's a wake up radio duty cycle that'll kind of go off. And then as you might imagine, that the wake up radio is either awake, where it could either receive those wake up radio frames, or it's in the doze state, where it means everything's off. And if you could send something to it, then it's, they're not going to obviously be received. Now with the wake up radio duty cycle, that you could also send a beacon. Now, a lot of times people think of the beacon that 802.11 sends out. Well, that's to kind of give the indication that there's some traffic. Well, it actually does more than that. The thing that does more than that, it keeps you synchronized in time. There's something called the TSF timer. And so therefore, what you could end up doing, what you want to be able to do is that if you're going to sleep, you need to be able to kind of sync yourself back up in time, because your clocks are going to shift. There's the access points, it's got a clock kind of going, and then there's the clients that they have. And it doesn't take too long until that they become, that these clocks will shift. So therefore, that when you would go to wake up, if you didn't actually sync back up again, you would wake up and they're going to be out of time, and so that they would be out of sync. Maybe like, football, you go for a pass and somebody is already way far down the field and you're just out of sync. What you need to do is kind of keep in sync that time. And that's basically why you'd want to do something like that, just to send that wake up radio beacon. Now that wake up radio beacon is sent in the format of the wake up radio, and it's strictly just sending the synchronization information so that the client can stay within sync. So what does that wake up radio packet look like? I'm trying to give you an idea. So the beginning part is just like pretty much all the other standards you kind of that 802.11 kind of comes up with, is that there's one of the strengths about 802.11 Wi-Fi is that it's backward compatible. How do they do that? The way that they do that is that they make the legacy preamble still valid for the newer radios. So therefore, older radios will be able to detect and say, oh, I know that there's some kind of transmission. So that transmission is not for the wake up radio itself, it's for everybody else that is running over Wi-Fi. And it's to let those other clients know that there's another transmission that they're not going to be able to decode, And so they're going to have to know that, hey, they need to hold off. 802.11 is called, there's something called the NAV, and that's kind of like the virtual carrier sense. And basically there's a time that's in there that says, hey, you should hold off on any transmissions for the length of this transmission. And so that's what that legacy preamble is about. Then at the very beginning, then it's where the wake up radio transmissions are specifically being designed to receive. There's a sync happening, and then there's the actual wake up radio data that would end up kind of going off. And this is a different PHY type. So this is not like specifically, for instance, 802.11n and so forth. This is for this type of technology, the thing that was being looked at was on-off keying. And there's some PHY types that are kind of looked at in the past. And what they did was they kind of said, well, we've got this OFDM stuff. They kind of came up with a hybrid, which is multi-carrier on-off keying. Since you've got a number of carriers, I just kind of said, well, let's kind of come up with that. It sort of made sense to them. So it's so MCook is a hybrid between OFDM and on-off keying. What are the different frame types? So that you'd actually, if you were sniffing the air and kind of, and you did have a wake-up radio receivers to kind of decode them, what you'd end up seeing is there's the beacon, which I talked a little bit about, is that if you were doing something where you're trying to add a duty cycle to kind of listen to see if there's something for you and be triggered, there's this wake-up radio beacon. And that's basically if there was no wake-up radio command being sent to the device, then send the wake-up radio beacon to at least go ahead and send the sync information. And then also that there's a wake up command, which, obviously, and there's also like a short version of it. And then there's a discovery frame, which is, obviously useful. And that discovery information is also kind of sent if you're trying to connect with the main radio to associate. And that also in the beacon and probe responses of the main radio, that same information will be sent there so that you can understand and say, oh, I know that here's an access point that supports this wake up radio feature. If you had several of them available, you can pick the one that actually supports it. And then they also have this wake up radio vendor specific. For people familiar with 802.11, that there was a lot of vendor specific information that was kind of brought in, and then they kind of had to figure out, well, how do you decode this vendor specific? And they kind of came up with a way to say, okay, this is vendor specific information. Here that they kind of like actually just called it out and said, hey, look, if you vendors want to put in something special, put it in this type of frame. So what exactly does that do? I've got no idea. Yeah, that you'd have to wait till somebody actually comes out with something. Miscellaneous type of information. Well, how do you set up this like duty cycle? How do you know that some devices is in this mode? There's this mode setup that kind of happens. And then also, like, how does this actually work as far as, is it something that's sent out? You could send it out to an individual client. Also, you could have this like broadcast out or like to group addresses so that if you had a series of devices that you wanted to wake up, you're able to do that. And there's also the way that it kind of gets sent out. There's a basic and then there's an FDMA version. So people that are familiar with the 802.11ax, and when we talk about OFDMA, you know that you can kind of send to multiple clients at once. And so this is kind of like using that same type of process to say, if you're going to send it to an individual client, then you'd send it out as a basic WR frame. If you wanted to send something out to multiple clients, so maybe several, but not like a group address. A group address would still be just one. But if you had like 2 or 3 that you wanted to kind of send out, you could send that out via the FDMA. I believe that's an optional feature that you kind of go off with. There also, you might say, well, does this mean that somebody could actually just kind of go off and send out these packets to wake up clients and therefore eat up their battery? They did think about this, and that this is very similar to the management frame protection, that you're able to protect those packets so that the client, when it receives it, knows that it's actually it's coming from the access point that it's connected to, so that it's not somebody randomly sending something off. And then finally, you're talking about, well, when is this actually coming out? This is very far along the lines. I would expect that the publication to be at the end of this year or the beginning of next year. I'm not expecting like any more revisions of the draft to be done. If there are, I would expect them to be pretty minor. So if you have an idea of what, what you're seeing today, it's probably going to be close to, if not the exact final version of the amendment. So with that, I think I want to turn it back over to you, Kelsey, and see if there's any questions.
Of course. Thank you, Dave. Just to get started out, I'll go ahead and catch up on some people who are tuning in as the rest of you drop any questions you have in the questions panel. I noticed Anders is back from last week. Thank you, Anders, for joining us. You should be receiving your 7Signal merch in the mail soon, actually, as well. Who else do we have here? We have Richard joining us from England. Thank you, Richard, for joining us again. And we have Jeffrey joining us from home in Connecticut. Thank you, Jeffrey. Let's see here, Dave. Our first question that we received was actually from Jim Vada, and he wanted to know if the wine was delivered. Very, very important to know. So what's the update with that?
It was.
Okay.
I did see Nathaniel kind of like walking. I'm in the front, and he gave me the thumbs up with the case of wine. I haven't actually inspected it to see that the bottles are unbroken, but he did give me the thumbs up so that it's received.
Awesome. Well, that's good to know. Better than the last time we had our broadcast, so that's good to know there. Okay, let's see here. Jim also had a question, and he asked, I just missed it here. How long can the main radio sleep? Indefinitely?
That's a good question. I went and I looked at it, and I kind of like looked at the duty cycle. And the duty cycle that they had set up was, if I did the math correctly, I just kind of like did it on a piece of paper, and it looked like it could go for maybe almost 5 hours. And that kind of like long duty cycle, it does kind of like make me wonder, because that just knowing, just with the current radios, as I was talking about before about sending that beacon out, you have to be able to be synced up for that duty cycle. And if you've kind of gone and your duty cycle is almost 5 hours, yeah, I know you're not going to be in sync. And what do I mean by that? That the access point is going to think that you're supposed to be awake, and the client's going to say no, that it's not waking up for a while, and it's going to go off and send the signals to the client, and so that they're going to be out of sync as far as time, and so therefore, using that amount of time is really going to not really work out, and that's where that the vendors have to kind of think about, well, what do they want to do? Are they thinking, well, okay, yeah, you're not going to be in sync, but you would recover. And then kind of figure out, to kind of come back in line and sync back up again. Or what you could do is you could just have the wake up radio just constantly on all the time. And then you draw basically that, residual amount of energy when the device is in receive mode. So basically the answer to the question is, by my math, 4.77 hours for the duty cycle. Are you really going to use it that long? I'm not really expecting so.
All right, thank you, Dave. Our next question is from Chris, and he wants to know, any idea of possible expected ratification timeline for 11BA?
Yeah, that's basically that if people are familiar with the process of getting something from coming up with an idea, so that you can then say, okay, now with this idea, get an approval to work on that idea. That's been done. Then you actually kind of have to work on the draft, and that's been done. Then there's something that, so then that within the working group of 802.11 that they have to get approval, that's all done. Then after that, there's something called sponsor ballot. It's already kind of gone out to sponsor ballot. So that's all done. And then after that, it then has to go that there's an approval process between at IEEE itself. And those are usually, they kind of look things over and say, did you kind of go off with sponsor ballot? Did you address the comments that were received within the working group? Did you listen to everybody and did you address those comments? So it's kind of as long as you did everything that you were supposed to do and you have all your paperwork done, you would expect it to be, approved. And that should be later on this year. And then they kind of get into the publication process. And so it does take a little bit of time to do the work of, okay, there's this amendment that you have, making sure that everything lines up and fits within the original standard. And so that's where I was kind of saying, I'm expecting that the publication to be out at the end of this year, beginning of next year. And I'm not expecting it to change, especially not, I wouldn't change. I'm not expecting it to change at all. And I would not expect it to change significantly. So if you do have looked at it in the past, you probably do have a pretty good idea of what's going to be coming out.
Thank you, Chris, for sending that question in. We have another question from Anders, and he wants to know, how much power can I expect to save if my IoT devices use 802.11ba instead of current technologies?
That's an excellent question. And one that I was going to look at, and I didn't do a full analysis of it. You can look at some of the initial study group work that was done. And the reason why I did get a little confused when I looked at it was because I believe when I looked at it, they were citing numbers from the, what is it called, OK, which is a single carrier, not the multi-carrier, which is 82.11 is using. So multi-carrier, you obviously got more carriers, so you're going to be receiving more. And so I wasn't sure how much that would kind of change the numbers, but that there are, I would say that definitely there's going to be some significant improvements. Where would you actually see this? And this is going to be on these type of devices where the device is not really active like most of the time. Maybe if it's something like a mouse where you're moving it, when you move it around, that's when that there's actually some transmission. But if it's just sitting there, that's not really doing anything, and there's no real communications going on. And so those are the types of devices that are going to see a dramatic amount of improvement. But I don't have any real numbers for you. But that you can kind of go off and look, and they do kind of announce some of the numbers. So I don't want to be premature and give out some false hopes. I did look at some of the articles that were out there, and they did kind of give out some wild numbers as saying, oh, you're going to get these tremendous power savings. I do expect some very good power savings, but I didn't want to be overly optimistic since the actual phi type was not what was referenced in the work that was kind of leading up to it.
Great, thank you, Anders, for that question. We have another question from Nikita, and they would like to know what would be the migration path for existing devices, firmware upgrade or more?
More. Those, as I kind of mentioned, that's if you really wanted this, that you would end up having to have new radios, and that's both on the access points and on the clients, that you would have to kind of go off and see that, oh, this supports 802.11ba. I don't know offhand if the Wi-Fi Alliance is going to have a certification program for it. Typically, for anything that's going to get some traction, that you typically need a Wi-Fi certification process. So I would look to that to see if it's really going to take off. I don't see that as too big of a problem because on the client side, you're going to buy. It's not. I'm not really expecting people to worry too much about like your laptops. It's going to be more like the watch that you wear, or some other device like an alarm or something like that. That's you would use this type of technology. So that would be built in. And then if you find it, yes, you do have some of these devices. Yes, you do want to have an access point that supports it as well. When would those type of devices come out? That's an excellent question too. And I don't have an answer to that as well.
All right, thank you for that. I believe we have time for one more question. I see one here from Fabiano, and they would like to know, when do you expect to have the new hardware 802.11ba in APs and devices?
Yeah, that was the one that I was just, that's a good question. I'd like to know that too. I would expect if it does, what you'd end up seeing is, look to see that a Wi-Fi Alliance certification process happens. Typically, if it was a new, PHY type, that what ends up happening is that when the standard is actually getting published, that's along the lines of when you see a lot of the hardware. Sometimes there's some early adopters. And so some of these smaller programs, that's what you end up seeing is that it kind of comes out a little bit later on. So I would say look to the Wi-Fi Alliance to see if there's some kind of certification. That would give you an idea of if there's actually going to be some products that would go along these lines. And then you'd also, one of the things that you could do is you could also look to some of the people that have worked on the standard. If you wanted to know that there's the submissions, the drafts themselves are not made public, but all the submissions that are done prior to creating that are public. For instance, I kind of referenced, a couple of them. And so therefore, you could just kind of look at those and see who they're submitted by. And that when you attend IEEE meetings, you have to say your affiliation. It's basically who's paying your check to be there. So it's kind of like your employer typically. And you could just see, well, who's the employer? And then you could just reach out to their marketing departments. Probably not the actual person that made the submission, they're not going to know. But the marketing departments of those companies would be able to kind of answer those types of questions.
Great, awesome, Dave. Thank you for answering all of those questions. Thank you to you all for putting those in the questions panel. We've really enjoyed having you all today on our webinar. It was a great topic, and we look forward to hopefully having you all join us next week for our webinar. So thank you so much, Dave, and hope you all have a great rest of your week.
All right, thanks, everybody.
Thanks, everyone. Bye.